Good morning, grasshoppers. I wanted to share with you that I graded the papers that have been turned in. And in the second exercise that you had to do for this week, some of you jotted down valid, invalid, etc. But that particular exercise required the truth tables for each of those elements. And the reason for that is because I want to give you practice on doing truth tables. So just writing down the validity of it is not what I was looking for. Now, if you had that situation going on, just go ahead and do those truth tables, on your work and turn them back in, and I'll make adjustments for you. The notion of truth tables is designed to show validity. So we've been working on actually doing the truth tables. And one of the things that some of you have been doing them in blocks, and the problem with the blocks is that you're not showing the connectors as a block. And if you're going to use the blocks, you have to do that. So if P, then Q, and then the second premise is Q, you have to show both the block for P and Q, but then you have to show the blocks for the conditional and the and the conclusion. So if P then Q, P therefore Q, you have to show the blocks for all of those elements, both the variables and the connectors. So, having said that, just keep that in mind. Truth tables are, as I've shared with you, are very mechanical, and just like in arithmetic, if you if you miss a step, then the arithmetic is incorrect. So, where it says show the truth tables, that's what we mean. This week, one of the elements that I was going to show with you starts on page 373, and that is testing arguments for validity through the indirect method. What this does, it eliminates a lot of the minutia of truth functions and gives you a very quick, easy mechanism to determine validity, and it's called the indirect method. It's incredibly simple, but it requires, again, methodical mechanics, and you have to lay it out right. So on page 373 here in your book, it gives us the beginning of the arguments. So you're looking at that argument. If not A, then parentheses B or C, and you can read the argument. Now you'll notice the way that he has this laid out. Now technically, what you need to do is to fill in all the truth variables for this argument. But the important notion that you need to remember is what you're attempting is to make the conclusion false. So in this particular case, if C, then A, you want that to be false. So you want that connector to be false. And then you want your premises to be true. Because if you can create the situation where the premises are true and the conclusion is false, you know the argument is invalid. And so that's what the agenda is for this indirect method. And on the next page, he starts giving you the layout for how to do that. So we already know in the conclusion that if true, then false is false. So we've falsified the conclusion. Now those now those variables for C and F that you've created in the conclusion, They have to be the variables you use in the premises. So when we go to the premises, you can see these truth values are transferred to the first premise, blah, blah, blah. You can see how uh, they're relaying those variables from the conclusion into the premises, except for not B. And what you want to do is make that true, so not B has to be true. So B has to be false. And that's the way you convert that. And anyway, he shows you in a very methodical fashion how to arrive at this particular argument. And at the bottom of the page, it shows that all the premises are true and the conclusion is false. And, and so that demonstrates that you have a situation where with true premises and a false conclusion, and then the conditional, that's false. So, the argument is invalid. Secondarily, if you're unable to do that, if you're unable to make the conclusion false, and then transfer those variables into the argument, then the argument is valid. If you're unable to make that conditional false. Remember that all arguments are conditional statements. So if P is a case, then Q is a case. To show a valid argument, just if you want to have some fun with it, do a modus ponens. If P, then Q. The next premise is Q. I'm sorry, the next premise is P, therefore Q. So if P, then Q, P, therefore Q. And you can do the indirect method quickly because that's a very quick argument. And what you find is that you make the conclusion false, and given those variables, in this case, Q is false. If you do that, you're unable to make the premises true. There you go. So, I want you to go through with the indirect method, and I want you to get some practice with that. So I'm looking at your syllabus, and we don't have the position up yet, but on exercise 6.5, Roman numeral 2, I want you to do numbers 1 through 9 using the indirect method. And I'll put that assignment up for you. But I want you to do that. And again, this is just practice for you to utilize the indirect method. And the importance of this is that when we go from doing regular truth functions, truth tables, to the indirect method, I always love the indirect method. It's just very cool, and it's very fast. And the next stage that we have, which you're into in terms of this week, is recognizing the propositions for come on. Okay, for the argument forms and fallacies, which starts on page 381. Now, the reason that you're doing these, starting these this week, and then next week we'll get some more practice with it in our final week of class, is you do truth functions to demonstrate validity, You do the indirect method as a quick, easy way to test for validity in an argument. But now you're going to look at actual argument forms. So, for example, they're giving you these modus ponens here down on the bottom of 382. Modus tollens, pure hypothetical syllogism, disjunctive syllogism, things of that. Those are some of the titles. And we're only going to be really worried about the first 8 rules. But you're going to want to memorize those so that when you see an argument and it has the form of a hypothetical syllogism, then you immediately recognize it's a valid argument because all of these forms are valid. And one of the things that I noticed is in a hypothetical syllogism, the syllogism can either work from the top. I think they actually give you an example in here. It can work from the top or it can work from the bottom. So if P then Q, if Q then R, therefore if P then R. Now you can turn those 2 premises at the top, you can turn those upside down and you'll arrive at a particular conclusion. And given that form, it's valid. There's an example that he gives you. I saw it in there this morning, and now let me see over here on where did I see that? Well, in any event, you know that it works both ways for the hypothetical syllogism. So these are good, easy mechanisms for determining validity in arguments, and that's what we're looking for this week and next week. That indirect method, what you're going to find is that's just a very quick mechanism, and I'm sure that you're going to like that a lot. All right, I will get that assignment for practicing the indirect method up on your board. Again, I think you're doing fine. Remember, this is just a brief or broad overview of just giving you a good handle on some logic. Okay, so you have a good week, and I will talk with you soon.